So we now all know that what is atom, how it is composed, and how it works. Atomic number, atomic weight, molecular weight, whatever we already know. Let's go from here. We already know that in case of atom, outside electrons move and this is negative charge. So these electrons, okay. So these electrons in the atom kind of set up a shell that's surrounded by the nucleus. And the shell is closest to the first shell is closest to the nucleus, then second, then third, and then so on. So the fact is that electrons are moved around the atom and with different energy level. So the movement of the electron around the atom we normally do as a count as a orbital on the basis of its different energy level. So we have the first shell, we say the s orbital, and this is very close to the nucleus. Second shell lies further from the nucleus, third and fourth shells even more further from the nucleus. Each shell contains subshell called the atomic orbital. So this is our first shell S, and second shell S and P, third shell S, P and D, fourth shell S, P, D and F. Now how many electron maximum can be stay or move in every shell? Because you remember, I think yesterday I told you that first shell maximum 2 electrons, second 8, third 18. But how it is come, it should be clear concept, correct? Should have. So now you could see the first shell number of atomic orbital is 1 and maximum number of electron 2. Second shell we have S and P. We already know that S can be the 1 orbital and maximum 2 electrons. And in case of P, we have the 3. So total actually we can say that P is 6 and S we know the 2. So actually 6 plus 2 comes 8. Similarly, here we have this type of subdivision, and as a result, finally we have maximum this amount of electron can be moved. Even the fourth shell 32. So now I think you guys are clear that how actually the electron distribute in every shell. Now let's go back to the next. You can see here, I told you that if we cut the onion, we can see like that ring and ring inside. So this is actually the things. This is the nucleus, and this is the first shell, second shell, third shell. So first shell equal to 2 electrons, second maximum 8, third maximum 18, and so on. Now we need to know the valency electron or valency shell, because we sometimes say, oh, oxygen have a 2 charge, or because this depends on the number of electrons in their outer shell, and outermost shell electron is actually called the valency electron. Now let's see here the n equal to 1, see the S sublevel, n equal to 2 SP, n equal to 3 SPD, and P, I told you that P have a 3, so PX, PY, PZ. So this is how it's subdivided. So my purpose or intention to let you know this explanation, because if you know this basic, then it's very clear when you go back to the periodic table, correct? Otherwise, suddenly periodic table and count the electron is little difficult. Now you could see here, and we also already learned from the last class that electron when move or gain any subshell, they try to be stay as a spin but opposite direction so that magnetic force can be cancelled. So they normally live in a pair, but we have some condition that if the electron at the same energy level, they cannot be stay at pair. And that time we learned two topics, the paramagnetic and diamagnetic, correct? Diamagnetic when they reside in a pair, and when the finally you will see something like unpaired like that, that means this is the unpaired and para, and if this is pair then diamagnetic. Actually this is the number of electron distribute in different subshell. Electronic configuration of atom, we have three rules, but if you look into here, the closest subshell to nucleus, lowest energy, and the energy level is increases at the distance of electron from the nucleus increases, correct? So this is the reason, and also in later you will see the higher energy level electron can escape faster than the lower. However, sometimes we have lots of exception we need to be take care when we study. It is important to remember that the closer the atomic orbital is to the nucleus, the lower is its energy, as we saw here. So first orbital is closer to the nucleus, it is lower in energy than 2s. Similarly, 2s orbital is lower in energy than 3s, and so on. Oh, by the way, if we know the rules, it will make you more interesting when you read the periodic table. An electron always goes into the available orbitals with the lowest energy first. So electron will first go here, then here, then here, as usual, normal rule. So this is our first rule for the distribution of electron or the configuration, whatever you say. Second rule, no more than two electrons can occupy each atomic orbital, and the two electrons must be of opposite spin. That means if one is up, one is down. That we already know here. Rule 3, when there are two or more atomic orbitals with the same energy, this is the one thing that sometimes we need to consider when we talk about the paramagnetic, diamagnetic. So if we have the two or more atomic orbital, electron in the orbital, same energy, the electron will occupy an empty orbital before it will pair up with another. So if when they are same energy, and then they will look which orbital is empty. So they will try to fill up the empty one first and then consider the pair up. For example, the carbon. So now the core electron, the electron in the inner shell. Inner shell means here we go, the and outer shell is the outside shell. So this one. The electrons in inner shell, those below the outermost shell, are called core electrons. Valency shell electrons, the electrons in the outermost shell, are called valency electrons. So valency electrons are very important. We know that calcium have a 2, chlorine have a 1. So when you will know the atomic number, and you can now draw the configuration, that first shell 2, second shell, so you can distribute the electron number of any element by drawing like that. So if you any element from the periodic table, you can draw like that. You can draw some ring, and you can say that, oh, I know the first shell S and maximum 2. I know the second shell SP and maximum 8. So this is how you can draw the electron. Like in case of oxygen, oxygen 8, correct? So first shell 2 and then second shell 6. So this is how any type of element, electronic configuration of any type of element, you can draw now by yourself, and you can know that what is the valency electron of that element, because valency one is the outer shell, and this is actually most important in practical life when you will write the formula, chemical reaction, etc. So next we have some example here. How many valency electrons do the following atoms have? Sodium, boron, nitrogen, oxygen, fluorine. So like if you do here, in case of sodium, so 2 and 8, 10, and outer shell 1. So the valency electron of sodium is 1. If you consider for the boron, the first shell 2 and then 3. So that means the 3 will be the outer shell. Nitrogen's 7, so that means the 2, and seconds 5 remaining. So 5 will be the valency. In case of oxygen, 2 and 6. So like that. So when you have the higher number, higher atomic number element, you just need to draw and you will find the answer. How many valence electrons do chlorine, bromine, iodine have? So that you can practice. And here this is in case of iron. We had the little bit of exception here last time we see, so we will go there. And here's some example how you can draw. Here's some example you can practice. Okay, here's some example. I will go back to the lecture, but yeah. So I also told you guys that octet rule, why we need this. An atom is more stable if its outer shell is either filled or contains 8 electrons. This is already established by the scientist in 1916. So, and it has no electrons of higher energy, also known as octet rule. Even hydrogen end with the 2 electron hydrogen lithium, and that's an exception. As I said, in chemistry, you will see the rules and also the exceptional things. So, this is the reason actually the outermost shell number of electron is important in making the ionic bond that we are going to today study. And orbital, we know the shape and orbital. So if you have a time, you can see. And here the some example of like helium, hydrogen, helium, and calcium. Sometimes what we do, we do the shorthand, like shorthand notification note and shorter form. So what we do in the periodic table, we have some noble gas like neon, helium, argon. So when we see the electronic configuration which have the number, atomic number more than 10 or more than 18, sometimes what we do, we don't write the first like 2 to 4 and 2 6 10. So what we write, like here this 10 and this equal to actually which one, argon, oh sorry, neon 10. So sometimes you will see that written like that, the neon and then from here. So this is called the shorthand by using the noble gas like neon, argon. We often see this type of things we write with the higher atomic number electronic configuration, and it is accepted. So this is the basic I wanted to share. Now I will go back to the orbital T2, just few minutes more, and then we go back to the our lecture 3. I can already keep continuing because then it will save our time. Okay, just a minute. So do you have any question now here? The electron distribution of, yeah. So now when we will see the periodic table, we will easy to read that how also we can write the configuration using the periodic table. So actually we saw, last time this is s orbital and these are the p orbital and here are the d orbital. So actually s n equal to 1, 2. So actually this is 1s, 2s, the way we learn. So when we actually count the configuration, for example, let's consider the oxygen 8, correct? 1s2. So 1s2 means here. This 2 electron is here. This is 1s. And then what we know? 2p6. So we know the p is here. P is this one, this second one. So 1, 2, 3, 4, 5, 6. Got it? So this is how we also can count. Now, if we consider the sulfur is 60, correct? So 1 is 2, huh? So this 2. Okay, let's come here. Lecture 2. So we are here because, yeah, let's go there. Yes. So that way now it is now very easy for, it will be very easy for you. So this is like n equal to 1, 1s, 2s, 3s, 4s, 5s, 6s. So normally this is, or these all are the d, and here we go the f, and this all considered the p orbital. Now if you want to count the electronic configuration, that means number of electrons for any element, then we will count like that. Like this one is like here 1s, we know the maximum 2 electron, so this is 1s, and you can see the 1 electron here 2, and 2s, 1s2, 2s2, so this is also the 2s2, and 2p6, 1 2 3 4 5 6. Got it? So any type of element you hold here, you can count also like that. But most easiest way, I mean quickest way, I show you. This is also the actually the scientific way, but periodic table also helps to write you the same electronic configuration. For example, let's go here. So these are s orbital, these are the d orbital, these are the p, and these are the f. Now for oxygen, look, we look, oxygen is here, as it's a 2, see, 1s2 and 2p6. So 2p6, here is a 2, so 1 2 3 4 5, I mean we consider from here, so it will come the here 2p6. But next we see the another example. Here you look, somebody asked me that I could not understand. This is actually the same configuration that now we just saw. The 1s, 2p, 3s, 4s, 5s, n equal to number 1. And this is the electron pairing ratio from here, like 1s, and then 2s2, 2p6, 3s2, 3p6, 4s2, 4p, but before 4p we have the d. See here, go back. So 1s2, 2s2, 2p6, 3s2, 3p6. But if you see here, here is no the d. Look into the here. Here is no d. Here is no d. Here is no. But here 4s we cannot jump 4p because we have the 3d here. Correct? That is the reason is here we can write like that, and when we write like that we can also show the pairing, I mean spin way. So this is actually, that's how we write, and we can show like that. 1s2, so we can write that 2 dot, 2s2 2 dot, 2p like 6 dot, like that. Here is a 2p 3, but just showing that this is the same drawing that comes from here. And even you see the orbital theory we saw, we can write from here also. So the one I was talking, the sulfur, 1s2, 2s2, 2p6, 3s2, 3p4. Here we have. So now if we see the sulfur, you can write it. So how it comes? Yes.
For like testing stuff, would we be allowed to use?
Yeah, you can. Yes.
Yeah.
I mean, periodic table is always allowed. Yeah, and also I saw the book, you know, the your textbook Jumadel. I saw that the book have a very nice periodic table. Some periodic table have all the elements electronic configuration. So if you just look into, you cannot allow with the configuration in the exam hall, I think. But if you look, you know now how to do that. But if you look into that, you will able to find how many are the exception. Like in this slide end up, they already mentioned D4 and D9. So there are some at the D4 and D9 a little bit of exception. Even in case of iron, they don't follow the regular octet rule that the higher lowest energy electron go, and then if you need to jump the electron either to gain or either to lose, from the highest, but sometimes they don't follow the rule, that they have a deviation somewhere, so you could able to see it over there also. Yeah, now I think if you look into it, will be more clear for you guys. And I want to show you this one now we know also. And finally, I want to show here. Here, D4, D9. Actually, these are the exception place who doesn't follow the octet rule or the regular rule for transferring. So you guys can look into here. Now I will go for the lecture 3, and here I want to show you something. Even I have here too. Is this the lecture? Yeah. Okay. So how many following ions or atoms are diamagnetic? See here. Now, if you look into these atoms and the electronic configuration, these two are diamagnetic. Diamagnetic means they are in a pair. How you understand? If we look into the others, you can see this is 3D3, 3D5, 3D5. They are at the same energy level, and they can't pair. They can't take their space as a pair. They go. The single unpaired. That's why unpaired are always paramagnetic. So here, that's why these two are diamagnetic. So when you will go to the practice, you will able to see some others also, that this is how we have to find out. So if you just draw like that, and you will find here. Need little bit of practice. Now we have a topic 3, basic bonding principles. Now you will see that your orbital knowledge, how it is translated in this chapter. We already know the what is matter. Now, in a broad sense, matter are divided into two broad categories called mixtures and pure substances. Mixtures are two types, homogeneous mixtures and heterogeneous mixtures. Do you have an idea about homogeneous and heterogeneous? Yes, like nowadays, so one temperature comes. So if we think that I need 1 glass of vitamin C drink, you can just take a 2 spoon of tang and you can dissolve in your water, correct? This is the homogeneous mixture. If you if you if you can dissolve any solid in a liquid or any of the two liquids together, they are completely dissolved, miscible, not any separation. That's called the homogeneous mixture. Like we will also go to the beach, but the seawater is not the homogeneous, because seawater have a pebble, rock, sand, correct? That are not dissolved in the water. So homogeneous mixtures are those mixtures which are miscible. It can be solid liquid, it can be the liquid, because oil and water never mix together, correct? So oil and water is a heterogeneous mixture. So that's why the homogeneous mixture of any kinds of matter, it can be solid in a liquid, it can be liquid. But if this is miscible, we cannot see anything, one phase system, then this is called the homogeneous mixture. And heterogeneous mixture are mainly, we can say this is not miscible, this is not one phase, it can be two phase, three phase. For example, oil and water. For example, seawater. There are so many. Like now, nowadays we do to drink energy, different types of energy drink. Those are the homogeneous mixture. You know, in the market we find different mixture of the fruit punch solution, juice. That are the homogeneous mixture. But if anything that are not miscible, like oil and water, in the chemistry laboratory, we often use different types of solvent like ethanol, chloroform, water to separation of the chemical from plant or some other. So when we take the different layer of liquid in a same funnel, and we will see the layer, they are not the miscible. So they have the different density, different melting point, boiling point. They cannot miscible with one another. So those are the two-phase, three-phase, or multi-phase. These are the heterogeneous mixture. Pure substance, elements and compounds. Elements, we already know the periodic table. Elements are the pure because that are the 100% pure. We cannot break it anymore. And compounds, when more than one atom in an appropriate ratio, they combine together by the chemical bond and make the new compound. So that's called the compound. So then we learn here that matter have a two broad categories, mixtures and pure substance. Mixtures are homogeneous and heterogeneous, and pure substance are elements and compounds. Here we see the some example. We can see here the carbon graphite, see here, they live in a complex, and they have not only carbon graphite, there are, you remember last time when we saw the solid, liquid, and gas, we saw the solid molecules are arranged in a very tough and very organized way. So this is the carbon graphite, this is sulfur, this is oxygen molecules, this is helium gas. You can see helium, mainly gas, are very disorganized, and liquid are not organized than solid, see, like that. And you will see another term, the molecules. All the molecules are compound, but all the compound are not molecules. So now you can see what are the then difference between the molecules and compound. As we know, the compounds made up of two or more atoms in a fixed ratio, two or more different atoms. And in case of molecule, mainly the two atoms, and many times you will see the same atom like Cl2, chlorine molecule, like oxygen, O2. So this is the molecules. So molecules, normally the two atom may be same or different, like water molecules, we will see another example. But compound has no limitation. It can be two or more different types of atom which combine in a fixed ratio, fixed or whole ratio of number of each atom, we call the compound. So in that case, we will say whatever the molecule, we study the compound, mostly compounds. Some are molecules like water, chlorine, bromine, iodine. So we know that. And molecules we also call the compound. So we will focus on the compound. Next, here we go, the compound, the thing I just said. So water molecules, carbon monoxide molecules. Here is a sodium chloride, the complex solid compounds. Some examples. And we now know the difference between molecules and compounds. Molecules, mainly the two atoms of same or different, not more than that. But compound can be unlimited, but the ratio should be the whole atomic ratio. Now the diatomic molecules. Diatomic molecules actually the same atom. When the two atoms make a chemical bond between themselves and form a diatomic molecules. For example, you can see here the hydrogen H2. So two hydrogen bond together and make the hydrogen molecule. Nitrogen N2. That means we have here two nitrogen atom. They combine together to form the nitrogen molecule. Two oxygen atom, they combine chemically form the oxygen molecule. So this is called the diatomic molecules, and you will must have some question, multiple choice question that can which are the diatomic molecules or which is not. So these are the actually example. Mainly we see in the chemistry, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These are the diatomic molecules. Ionic versus covalent bond. what first we need about the bonding? Bonding means when two elements or two things associated by something. So here the chemical bond associate two elements, and chemical bonds mainly two types. We have other than that also, but mainly our discussion here is two types of chemical bonding, that's called the ionic bond and covalent bond. Ionic bond is make between the metal and non-metal. So, for example, sodium metal and chlorine non-metal. We already know that in case of ionic bond, how it is formed by giving and taking electron. So sodium or mostly metal can donate the one or more electron, and they can make their outer shell octet or stable. And non-metal, if they have deficiency of electron in their valence shell or outer shell, they can take those electrons from the metal, and by giving and taking, they make the bond is called the ionic bond. For example, here we know now the sodium is 11, correct? So if we that now the electron configuration will work. So 2, and then just write 8 in case of sodium. So we have here extra 1 electron. So sodium, as I said, that every element wants to be stable. Even we want to be stable in our life, correct? That's why we are here. Huh? So this is the natural rules. So this, if sodium can lose this electron, then sodium will be stable. That's why sodium gives this electron. Try to find that who can take. In case of chlorine, I think 70. So if you do the first shell 2, second shell 8, and third shell 7, that means if chlorine wants to be stable, they need one more electron. So this sodium, one electron from sodium go here. So this is how these two elements go stable and they make a bond, and new compound is formed, and this is how ionic bond is formed. So the information you need to know that metal and non-metal make the ionic bond, and by giving or taking electron. And now I come about the covalent bond. Covalent bond actually created between the non-metal, two non-metals. So like for example, you two friends, one friend have a banana, one friend have a bread. But only eating bread is not or sometimes good taste, or only banana also not share. So two friends, let's share our banana and bread, and we both will have a nice breakfast. So here also have the same thing. Two non-metals sometimes have the loose or unpaired electron. So they want to be paired together by sharing their unpaired electron. So this is how the covalent bond form between the two non-metals. In our course, in this course, we will be mainly practicing the ionic bond, but some covalent bond also will have some topics. That time we will be discussing a detail. So now I think you got it the idea. In case of covalent bond, the unpaired two electrons, they come closer and then they make a bond by sharing the unpaired electron. Ionic bond, I think we already show it. So let's just go for a revision that how it goes. So the extra electron, the valency shell electron, the outermost electron, we say, so this is the electron of sodium, and that's why the ion is formed. And also we say the valence electron of sodium is 1, calcium is 2, magnesium is 2. Even we know some, we will see some transition metal that can be often donate the multiple electron. So we will also see later. So now I think you are very clear about it. So instead of sharing their electrons, some atoms transfer their electron from one to another when they form a bond. We know already the details. Oh, by the way, I need to note something here. So the metal or element who can donate the electron is called the cation or positive ion. And the non-metal or any element who can take this electron is called the anion or negative ion. Valency electron. Now we guys are very clear that what is called. Now you can see the table, periodic table shape, and where the, like in the first one is with mostly +1. Second 2. That means if we go back here, do we have any? Oh, we don't have any periodic table here. Anyway, let's go here. Okay, so if we look into just here, in mostly like sodium, lithium, potassium, rubidium, when we will do the electronic configuration, outer shell we will find the 1 electron. In case of here, we will find the 2. So that they are, they are kindly showing here. And this is called the transition metal, multiple cations. Like for example, I say that copper. Copper can donate maximum 2 electrons. But normally they don't lose the 2 electrons together. That's why we say that copper has the 2 charges. Copper +1, copper +2. That means copper can donate either the 1 or maximum 2 electrons. That's how when we will learn the name of oxide, we will find that cupric oxide, cuprous oxide. So we will also find iron, 2 or 3 maximum. So ferrous, ferric. So this is the transition metals or multiple cations they can form. And here similar, you guys have some example. But as I said, now you know the writing the electronic configuration, not only using the periodic table but also the orbital theory using. And that's very easy because 2, 8, 18, 32, this is most of them, if you know the maximum. So you can easily draw and come in a conclusions. So you can easily find the valency electrons and you can move on. Some compounds are called binary. Binary means, bi means 2, correct? So binary compounds means when compounds composed or formed by 2 elements. So it can be binary compound by making the ionic bond, by making the covalent bond. So we will be seeing here. So made up of only one type of atom, element, and in case of compound, we know the more than one. Now binary composed of 2 and only 2 different types of element. Not binary composed of more than 2 types of element. Compounds binary, not binary. H2O, example of binary, 2 compounds, HCl. But here if you see the CH3OH, this is not binary. So you have to say you have to make sure the compound is made of 2 elements, then it will be binary. As I said, the binary can be the ionic and covalent. We know the ionic bond is formed between metal and non-metal. Covalent compounds can be formed by the non-metal, between non-metal and non-metal. So we can find out that. So and finding out is not tough. The reason when you will say this one, you will find. Like if you see here, the iron, magnesium, those are the metal, correct? Copper. And when you will see the nitrogen, silicon, those are not metal. Oxygen, not metal. So when you will see the compound 2 non-metal, they are covalent bond. When you will see metal and non-metal, they are ionic binary. See here? So binary ionic compound, binary covalent compound, N2O4 binary covalent compound, CuS5 binary ionic compound, Cl2 element not binary because this is diatomic molecules, correct? Binary means two element, not two same, two different. But if this is more than two different elements, then this is not a binary, that's a regular compounds. So magnesium oxide binary, PF6 binary covalent compound. So you guys can finding out like that. Now let's move on how you will name the covalent compounds. Covalent compounds, we know the covalent compound is formed by non-metal and non-metal. For example, here sulfur oxide. This is sulfur monoxide. One sulfur and one oxygen. So how we name? Look into that. So first we will name the first element name. Second, we will write the second first of element, and then we will end with the IDE. See, write down the name of the first element, sulfur, write down the name of the second element and change the ending. So we need to end with the IDE. So use a prefix to indicate the number of molecules. But if we have the number more than one, then we need to also mention it. We are coming, but first let's see. We have to name the first name, like for example here sulfur. This is our first rule to name. Second, oxygen, but we don't need to oxygen. We will take the first half of the second element and we will end with the IDE. And this is the principle of naming of oxide in case of covalent. Even ionic, more or less close, not so different. So sulfur oxide. Now another rule that this, if you see any compound that doesn't have any prefix, that means the number of atom is 1. This is, please make sure. Like sulfur, we have here 1 sulfur. Oxygen, O, we have 1. But if you look into the second one, S2O3, that means we have the 2 sulfur atom here and we have the 3 oxygen atom here. So in that case, we have to mention, and we know 2 means di, 3 means tri, 4 means tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 octa. That's all. You don't need more than that. So normally di, tri, penta, hexa, hepta, that's enough. So we have to then mention disulfur trioxide. Rules for naming covalent compound. So write down the name of the first element and write down the name of the second, that is same. Use the prefix. So that's here you can see mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, and octa 8, nona 9, deca 10. Sometimes also you will see the exception, we will that time notify. Some example here, dinitrogen trioxide, disulfur, see dibromide, then tetraphosphorus hexachloride. So you have to be little bit of practice, then you will be very familiar on that. 2 important exception, as I said. If there is only one atom of the first element, you do not use the prefix mono. Like normally we say that di, tri, but in case of mono, normally we don't say, like here we should say the monocarbon dioxide, correct? But normally we don't say that. So this is the exception. But here, you say here, we don't say here, but second one, CO, carbon monoxide. This is also the same. Now anyone can ask that, why then we are telling? So this is chemistry, this is science. We will have rules, we will have the deviation of rules. I think this is also life. So we have to accept that. Name the following covalent compound, N2O5. So which one will be correct? Dinitrogen pentaoxide. Yes. So N2O5, dinitrogen pentaoxide. So now I hope that you will able to name the covalent compound. Now, naming of ionic compound. Ionic compound, we know the binary and then ionic, and we saw the within the binary, we saw the covalent. We already learned about the covalent. Now we will see the ionic compound. Ionic compounds are two types, metal, I mean the regular ionic and the transition metal. That means, you know, I just told that some transition metal like copper, like lead, Pb, like iron Fe, they have the multiple ion like can lose. So one, two, or three. So those are the name is little bit of different, and regular ionic compound name is different. Also, we have some metal and polyatomic ion. Polyatomic ion, we have some list of polyatomic ion. We need to actually memorize. We are going to talk very soon here. Now same, if we want to now name it, so metal and non-metal, the ionic compound. So first we need to tell the metal name like Na, sodium, then the non-metal name, chloride, first half, and then we have to end with IDE. Let's see here. See, write down the name of the metal, write down the name of the non-metal, and actually change the end to ending to IDE. So I will say that when you guys will review, you guys should focus on the example, because actually this is not so complicated. If you just practice more example, it will be very familiar and there is a nothing to forget about. So sodium chloride. Now let's practice here some. Like if I say now, change the color. This is not looking. Okay. So let's see this one. Calcium. So this is calcium chloride. You know, in case of covalent, we use the monodietri, but normally here we will not follow the same always. So that's the difference from covalent to ionic. Let's see here. See, sodium chloride, potassium, Kf means fluorine. So potassium fluoride, Ca(I2), calcium iodide. Here is a 2 iodine atom, but we will not say di. And now, very soon, I'm going to also talk the formula. That time, you will know that why here is a 2 or somebody here not. We will learn. So, why are there 2 I's in the formula CaI2? Because I think you guys know the formula writing. The easiest way to formula writing is the crisscross formula, the valency transfer. So crisscross formula means the valency of the positive ion or metal will go into here, and the negative ion or non-metal valency will come here as a prefix. So like sodium plus 1, chlorine all minus 1. So when 1, 1, we don't need to write here, correct? So that's why this is 1, 1 is nullify. We write the sodium chloride. Kf same. But in case of CaI2, iodine charge minus 1 and calcium is plus 2. So these two go to the iodine as a prefix, and this one come to the calcium, but one we don't need to write it. That's why this two came. This two is the number of positive or calcium, and this is also come from the the valence electron, how many electron they are donating or taking. That we are also going to see a little bit of more detail very soon. So always balance the positive charge from the metal with the negative charge from the non-metal. So there are a couple of ways to find it. The way I show you, this is the one of the easiest way, but you need to know the valency electron. Even if you know one of the two, any like positive ion or negative, any of your valency charge, you can find the another one. However, the another rule is to balance the positive and negative charge. Remember, always the positive and negative charge should be the same and equal to zero when any compound prepare. So here calcium 2 positive charge and iodine is 1 negative charge. So that's why here we could see like that. But you do, I think you guys know the balancing of chemical reaction. Yeah. So that's they are here talking. So if we need to be same the balance, so that means we also have to be put here the two, then we can make it the 2 calcium, and the positive and negative charge will be the like +2 and the -2. That we will, when it will the topic come, we will talk. So like calcium and oxygen, calcium +2, oxygen -2, it's balance. Aluminium +3, oxygen -2. So what we have to do, crisscross. If we want to balance it, we have to multiply here the 2, and here we have to multiply 3. So then 3 2 6, and 3 2 3 6. So +6 and -6 equal to 0. So this is how we have to do that. Transition metal and non-metal. If you look into here, in that case, this is called the copper oxide. But here, if you look into, we know the oxygen charge. We know the oxygen is -2. But here you can see that's why this crisscross oxygen charge come here as a prefix. And here is nothing. So you can easily find the copper charge is +1. That's why here is nothing. So that means this is called the Q plus. And that's we are going to learn that when the ionic compound for the transition metal who can donate more electrons, like 1 electron, 2 electrons, then the lowest number of electron donation name we end with the plus, P, OUS. And when the maximum number of electron donate, like copper can donate 2, so when we will name Q prick, IC. So this is Q plus. So OUS, lowest number of electron donation for the transition metal, we will end with OUS. And the highest number of transition metal to lose electron, we will end with the name IC. So that's we are also going to see now. So this is called the copper oxide. So name of the second element, IDE. So this is the regular name, the IDE. Same, the copper oxygen IDE. But coming from here, IDE, it's okay. But when we will, I don't know why it's not coming here, because copper is a transition metal. The copper atom can form +1 ion and +2 ion. We know that, huh? Now see here. So we can name two way. This is called the Roman way, copper 1 oxide, copper 2 oxide. But still we can say that Q plus and Q prick. I hope they have here in this book. Anyway, so we can also name, when the copper donate the 1 electron, we will say copper 1 oxide. And this is another name, Q plus oxide. Okay, just to make sure, because I'm not sure you guys have a final exam from the arts. They may have this type of Q plus oxide. So both are correct. Okay, both are two different way to name. Q plus oxide, OUS, and this is copper 2, so Q prick. So this one, and oxide. These two are both are correct. Okay. So if you just write the copper oxide like the sodium oxide, it will not the correct name. you need to know that this is the transition metal and it can donate the 1 or 2 electrons. So we have to either write this way, copper 1, copper 2, or we have to write Q plus oxide or Q pre oxide. Here we have some example, you guys can see it. Determining charge from formula. I think we already little bit of talk here. Let's talk here more. This is called cobalt, okay? CO, cobalt. Cobalt chloride and ferric oxide or iron 3 oxide. So now we always know that chloride always have negative 1 charge. Here is that's why nothing. And cobalt have obviously positive 2 charge. That's why as a crisscross formula, this charge came here. So that means here 2 chlorine atom. Actually, this is not the charge of chlorine minus 2. Chlorine charge is always minus 1. Now you know that because you know the electronic contribution, configuration. But here we have 2 chlorine atom, correct? So that's why chlorine minus 1 charge times 2 minus 2. In case of cobalt, we have, here we have just 1 because chlorine had a minus 1. So we will have the plus 1, but we have to multiply with 2. See, x equal to plus 2. That's why here is a plus 2. So this 2 comes, this is for the 2 cobalt when we will do the balancing reaction. So this is how we have to be find the charge, and always remember the charge plus and minus must be 0 when we will write the formula. So that's why here the 2 chlorine atom minus charge minus 2. Here we have the 1, but we have to multiply with 2 so that we can make the same balance equal to 0. So minus 2 plus 2 equal to 0. So if you look into now ferric or iron 3 oxide, so what we have? So we know the oxygen always have a negative 2 charge. So these 2 go here, and this is iron 3. Iron 3 means iron lose the 3 electron. So these 3 go here, crisscross. So now then oxygen we have minus 2 and the 3 comes from the iron, so minus 6. In case of iron, we have to be multiply, and we know that here we have the 2 iron atom, so that's why here 2. So if we multiply with the 3, we will got the, see here, we will got the plus 6. So minus 6 and plus 6 equal to 0. So this is how we have to find the charge or write the formula. What is the chemical formula of the ionic compound that form a plus 3 technetium cation combines with an oxygen anion? So let's see it. So technetium Tc charge is plus 3, okay? And we already know the oxygen anion. That means like that. So then which one will be the correct? Any guess? Yes. So this one. As I say, the crisscross, easy way to write the faster. So anion charge will come to the cation, and cation charge will come to the anion as a prefix. Now we will talk about the polyatomic ion. We already know that the metal can donate the electrons, non-metal can gain. So this is how we got the single cation and single anion, correct? But in our chemistry, we already have established some polyatomic ion. That means they already have either 2 or 3 ions sum together, and they have specific charge. So we cannot actually change, or why it comes now, we don't need to learn because it already established. But the funny part I'm going to tell you that when you will memorize the polyatomic ion, you will see only two or three cation, all are anion. Like ammonium cation NH4, hydronomium H3, H3O. Other than that, all the polyatomic ions are anion. Let's see here. See. So that's I mean the mercury one. That's I don't know why they give here. Maybe for the example, this is the single ion, but start from here. Nitrite, NO2. Oh, here I want to say, I think this slide should some extension. I don't know why they didn't give it, but I'm telling you so you guys can learn. When you will see the polyatomic ion similar, but with one end with less negative ion and one have the more negative ion. So we have to name like that. Nitrite, ITE, less electron one, and NO3, nitrate. Similarly, SO3 and SO4, sulfite and sulfate. You will again find similar. So like that, and there are also so many that doesn't they do not maintain the regular name formula. So you need to be memorized, and that's true, but that's not so difficult because all are here. So, and most common are here, like nitrite, NO2. Negative means this is minus one charge. If you see two negative, that means this is two negative ion charge. So nitrite, nitrate, sulfite, sulfate. This is hydrogen sulfate, or we also call the bisulfate. Negative, this is one charge. Hydroxide, we all know this is one charge. Cyanide, one charge. Arsenate, ASO4, this is three charge negative. So why we need to learn? Because you will see lots of compound. This polyatomic ion can make a bond with some metal or non-metal and make lots of compounds that we use regular basis in the laboratory or chemistry class. And you also need to write the compound or balancing the chemical reaction, or you need to write the chemical reaction. That time you need, and that's why it's very important if you can memorize this. Phosphate, PO4, negative 3 charge. Biphosphate or hydrogen phosphate, HPO3, this is negative 2 charge. So please try to be memorized. Like here I want to say, it doesn't follow any rule. See here, carbonate, CO3, negative 2. HCO3, negative 1 charge, bicarbonate or hydrogen carbonate. Hypochlorite, HCl, negative charge. HCl, ClO. ClO2, negative charge, chloride. ClO3, chlorate. ClO4, perchlorate. So sulfite, sulfate, see, ClO2, chloride, chlorate, but still have another one, ClO4, that name is perchlorate. This is acetate, C2H3O2. So dichromate, Cr2O7 and CrO4 chromate, peroxide. So for me, this here we go some, and these are manganese. This is also permanganate, oxidizing, reducing. When we do the oxidation reduction reaction titration, that time we use. Maybe in the future you will do the lab or more chemistry course, you will learn that time the lab. Did you ever do the lab class for this course? No, you do not have any laboratory. This is 3 credit course.
You have to take it for the next one. For chemistry 104, you would take chemistry 106, which is a lab.
Okay, so you have to first finish this. This is 4 credit, and then you have to, yeah, that's I'm telling. But in other colleges, they also have a lab in this course. Lab is good because so many things you could see, like the metals you learn, how it looks. Like metals are very good electric conductor. So laboratory you can see different types of metal, and we have the conductor. When you put there, they form the current. Like interesting. you are able to see the different metals like mercury, how heavy, little bit of mercury. So you also can see the reaction, but maybe in the next course they arrange like that. Yeah, you will able to see that. Now, covalently bonded ion that bond with metal. See, sulfate. This is SO4. They are bonding between the covalent, one sulfur and four oxygen atoms. See the ionic bond. See the copper sulfate. That's we are now talking here. So this sulfate ion, polyatomic anion, can make a ionic bond with the metal. So here we learn that sulfate have a -2 charge. And when you will see the no charge, that means copper is +2 charge. So if you see the positive ion and negative ion have the same charge, it doesn't matter. This is +1 -1, +2 -2. It can be +3 -3. That time you don't need to write the prefix. If these both are same, okay? So that's why here copper sulfate, we don't need to write as a prefix. This is also the example of ionic compound. So this is, we can also write like that, copper 2 sulfate. When polyatomic ion bond with metals, the compound that results are ionic compounds. We know, we already check it out. And in case of transition, we will use the Roman like 1, 2, or 3 in that case. Metal and a polyatomic ion. Here we have some example. Name of the first element, how you can name, let's now check it out. So first we need to name the first element, charge of the transition metal using Roman numerals. So whatever the charge we have, if this is the not transition, you don't need to worry about it. But if this is the transition, see here, we need to write as a numerals. Like this is copper phosphate. So this is, if you see, the phosphate have a -3 charge. So this comes crisscross is here, but here is nothing. That means this is +1 charge. So you have to write like that. Okay, if this is transition metal. Otherwise, you don't need to write. Like this is sodium carbonate. You know, we find the carbonate is -2 charge. Aluminium sulfate. Here, aluminium charge is +3, +3, and sulfate is, sulfate is 2, -2. That's why we write like that, aluminium sulfate. But remember that if this is the transition metal, then we have to must mention the Roman. And transition metal, not so much. Copper, iron, lead, and maybe 2 or 3 more. So you will able to know that, yeah, when you will look into. Understanding chemical formula. You must know the difference between atom and ion and how to break a formula unit into correct number of ions and atoms respectively. Now you know, we already learned the crisscross, we know the how to write the valency, so you guys are fine here. Now we have some example, and actually that's all about the topic 3. So let's see some examples here. Name the following ionic compound. See here, iron is a transitional metal, okay? So in that case, we already know the sulfate charge is -2. So that means here we have 3, this is the iron charge. So obviously then here you will find that this is the +3. So when you will write, you have to find iron 3 sulfate. Sulfate, you know, SO4, not sulfite. Correct? So this is how you have to find out. Is the formula covalent or ionic? Yeah, you will find it because when you will look into the, always see when the compound will come, metal always come first and positive comes. So when you will see it is not the metal, you will easily able to find out that this is ionic or covalent. Other than that, let's see what they said. Ionic compounds, metal and non-metal. We know the covalent. Here we have the polyatomic ions and binary also, non-metal plus non-metal. And polyatomic ion, we have to memorize. Binary compound, the prefix we need to know. And the metal, one cation and transition metal. So this is the 4 things you need to know. You need to careful when you write the name or formula. So ionic compound can be between metal and non-metal, and covalent compound between non-metal and non-metal. In case of covalent, can be polyatomic ions. As I said, the most are negative ion. So you have to memorize. And binary compounds, we need to remember the mono, di, tri, tetra to deca. And in case of transition, we need to be mentioned, if this is transition metal, we need to be mentioned the 1 to how many electron they lose, we need to be write in a Roman way. So this is the naming roadmap. This is very straightforward here. Actually, name is very complicated. I have lecture that I do in other. It's almost 60 or 70 pages when we go so many details. But I saw that your one is not so much long. The formula of vanadium nitride, this type of element or metal we normally don't use, but for your exam, as I said, which are usually we don't use, this is the exam material. So you guys are allowed to use the periodic table, so it's easy little bit of. But when you will see vanadium 4, you know the vanadium charge is +4, correct? So nitride, so you will able to find that nitrogen actually 3. So I think this one, let's see. Yeah, C. Because nitrogen charge is 3, -3, it will come here, and vanadium we have a 4, so it will go crisscross. Just quickest way. I always ask a student, just remember, if you have a clear idea about the electronic configuration, orbital, valency electron, then crisscross formula is the best way to quickest, write your formula, because you know that how the charge is coming by giving electron, taking, or the sharing, correct? So you can easily sort it down. Here is the another one we saw. Which of the following pairs is incorrectly named? Incorrectly named. Magnesium phosphate, dinitrogen pentoxide, potassium sulfide, cupric or copper 2 bromide. This one, dinitrogen tetrachloride. So this one, I think the correct answer. Yeah. So actually these questions are usually used for making the quiz or final, but we have lots of options. So I keep those questions here for your practice and for knowing the format, what type of question can come. So that's all for today. Which name is not matched with the correct? Nitrite, sulfide, perchlorate, carbonate, phosphate. I think this one. Let's see. PO4 phosphate. Why? Because this is the -3 charge, I think. Yes, see, -3 charge. That's why this is not the correct one. So that's all for today's lecture. Is there any new student here? Any new student that today first time you join class? Okay, that's very fine. We don't need attendance. The recitation 1 group we have done today, and recitation 2 group we have the recitation today, correct? So it is the time that recitation 1 group will be go, and recitation 2 group take your time and see group wise. See group, take your time, we have little time. So recitation 2 group, please see group wise and start your job. And as soon as you finish, you give it to me, you guys are free. And if you have any questions, now let me know. And have a great day, okay? Yeah, have a great day. You didn't find you? I hang it. Which section you are? Section. I mean, I are recitation 1 or recitation 2?
I don't know because I have a wrong option before. I want to add a process, but it's wife. And
So I think then I didn't find your name in the Clumicas.
right now, maybe you can find my name. Because
Oh,
before I do a wrong option.
okay.
So my name is Xuan Yuzhou. Today is
Very good. So do you have your name here? This is for the recitation one, university students.
no.
So then, uh, so what department say they will enroll you in the class? Yeah? So you already enrolled my class?
Yes.
Oh,
Right now
so
I
find
have.
your name. This is the recitation one section, and this is the recitation two section. So why don't you find your name? Maybe no, no, no. I will open 6 p.m. and maybe I will keep all time open. All right. But I will announce it in the back. All right. Your name didn't change? Oh, because I first give the priority.
On the attendance sheet yesterday, I
Uh-huh.
put an arrow saying that 5 of us started.
Oh, yesterday.
Yeah.
That's why, because I follow the day before yesterday. Okay, why don't you see it and today you have or Monday you have?
Monday.
Okay, can you just email me?
I did
So,
last night.
you did?
Yeah.
With your team member name?
And
Okay, I will
like,
check it out and fix it.
thank
Okay,
you.
no problem.
Yeah, no.
Nine, yeah? Yeah, that's the problem. So now you can work with any of your peers if you want, but I have so many students, they could not come here because class is already over, the 100. So you can come and join, but make sure the department allows it. So like this, yes. Oh, you don't have your room yet? Yeah, so that's I'm telling that you didn't communicate yet. Oh, okay. So I can show here. Okay, I will show here. Then maybe it will be easy. Oh, okay.